Alright, so today I'm going to talk about MapReduce. So, what is MapReduce? According to our friend Wiki, MapReduce is a programming model and an associated implementation for processing and generating large datasets with a parallel distributed algorithm on a cluster. In simple words, MapReduce is used to convert unstructured data into structured data with the help of an algorithm by distributing that data to different machines running in parallel to get the task done faster. MapReduce plays a key role in big data, also known as Hadoop. MapReduce is a part of HDFS, which is the Hadoop file system. So, where is it used? It's used almost everywhere. All of the social media we use these days runs on big data, which means without MapReduce, you won't be able to use YouTube. Other than this, big data is also used in the business and health industry. Did you know the search tools in YouTube, which filters search for the number of views or upload data, etc., is the process of MapReduce. So the traditional way. The traditional way is to get the big chunk of data and then split it into little pieces. Then you use the grep command, which is a Unix command used to search files for the occurrence of a string of characters that matches a specified pattern to get the matches in the data. And then you use the cat command, which is a standard Unix utility that reads files sequentially, writing them to standard output, and there you have your structured data. MapReduce way. The MapReduce way is the same as the traditional way, except that instead of using the grep or cat command, we use the mapper and the reducer, short for MapReduce. You get the data, you split it into small pieces, then you use the mapper to look for patterns or data belonging to similar categories, then the reducer groups them together accordingly to their groups, and now you have your structured data. Solving the problem with MapReduce. So the database is dumped into CSV format and copied it onto the Hadoop file system, from where the mapper reads the CSV file and tries to look for patterns or matches of datasets matching to similar categories. It then produces a result known as map logic in a CSV format, which is then forwarded to the reducer. So the reducer now groups those patterns or sets of data together accordingly to the categories and produces a result known as reduced logic in a CSV format. This reduced logic is stored back into the Hadoop file system. So this is how MapReduce architecture looks like. There's a name node which has a job history server and a resource manager. This resource manager is connected to both the node managers in the data nodes and to the client. So the data node 1 has a node manager which manages both of these containers. So the container which has the application master controls which data goes to the mapper or to the reducer. In the data node 2, there's also a node manager which manages the container and manages the reducer's task. So the MapReduce components. There's a client which submits a MapReduce job. There's a job history server which maintains information about submitted MapReduce jobs after their application master terminates the job. Resource manager. It's a cluster level resource manager. It has a long life and a high quality hardware. Application master. There's one application master per application. It has a really short life. It coordinates and manages MapReduce jobs, negotiates with the resource manager to schedule the tasks. The tasks are started by the node managers. The node manager, there's one node manager per data node. It monitors the resources on data node. Containers. They're created by the node managers when requested, and they allocate certain amount of resources such as memory and CPU, etc. on a slave node. So this is a MapReduce paradigm and also a really good example of MapReduce. So here we have our data, which is deer, beer, river, car, river, deer, car, beer. Now we split this big chunk of data into small pieces. So we get deer, beer, river, car, river, deer, car, beer. So we send it to the mapper. Now mapper assigns each of these words a value of 1. So we get deer 1, beer 1, river 1, similarly in the next of the two cases. Now this data is sent to the shuffler. The shuffler shuffles these data accordingly. So beer 1 means that in the first set there was one beer, so beer 1. There was no beer in the second set, but there is a beer in the third set, so it means beer 1. Similarly in car, there's no car in the first set. There's 2 cars in the second set, which means car 1. And the third set, there is only a single car, so we get car 1, which means 3 cars. Deer 1. there's deer 1 in the first set, there's no deer in the second set, there's a deer in the third set, so we get deer 1 1. Similarly for river, so we send this this data to the reducer. So now the reducer combines these data and says that, okay, there's beer 2, which means we had beer 1 1, so 1 1 is 2, right? So that means there are 2 beers. Similarly, car 1 1 1, which means car 3, so we have 3 cars. Similarly for deer and river, so we get, so in the final result we get there are 2 beers, 3 cars, 2 deers, and 2 rivers. So for a bonus in this video, I can actually show you how a MapReduce program actually looks like. So wait for it. Okay, so this is how it looks like. This is the mapper, so it's gonna get the data and map it. This isn't a map. This is a mapper extension. So this is gonna this is like a shuffler. So third is the reducer. So here we get the data from the mapper and reduce the data accordingly, and here we have the output. Thank you so much for watching.